Hey everybody, so I wanted to actually review the Buggy Lab that we did. And if you remember, we had a buggy, a phone as a timer, and a meter stick. And what we did is that we actually laid out the meter stick on the floor. We actually had 2 meter sticks, and I'll just kind of make a note of that by sort of dividing it down the middle. So we had like 100 centimeters here, or 1 meter, however you want to put it. And we go from 0 all the way to 200 centimeters at the end here, right? And what we did is we'd actually have a little buggy that we'd set up right here at the beginning mark. And our goal was to actually track the progress of the buggy and record 1, 2, 3, 4, 5 positions and 5 times as the buggy ran. So what we'd end up doing is we said, and we did 2 things actually. In one trial, we ran the buggy going forwards. And then in another trial, let's see if we can change this around, we actually had the buggy start from 200 and go backwards. So the first trial, again, we go forwards. And in the second trial, we had the buggy roll backwards. And what we did is that we had a table for going forwards. I'll call this forwards and I'll call this backwards. What we ended up having is we constructed a table that had time and position, and we'd end up getting 5 trials. So going forward, we'd start off at 0, 0, and then we wind up at some time and a final position of 200 centimeters. Excuse me. Running backwards, we'd start off at a time of 0 seconds, and our position was 200 centimeters to start with. Now here's what ends up happening. We ended up getting 2 graphs. So for our forward trial, we got a graph where it would look like this, right? And we would get our points plotted, so maybe something like this. And then we'd actually draw the best fit line through the graph using a program like, say, Wolfram Alpha. And we'd end up getting an equation that looks something like this. It would say something like y equals, I'm going to make up a number. We'll say 0.4x plus 0.05. I'm just making up numbers. Now here's the thing. What we realized is, yeah, this is a linear equation, but it means something very specific. And although this line equation works for algebra, we need to be a little bit more careful for physics. So we did a little bit of letter replacement. We realized that the letter that we're calling y in the formula is actually the position of the object. And so we denote that as x, which means position. The letter that we're actually calling x here, and you know what? I'm going to use a different color. I'm going to write it in purple. So x is position. The letter that this dark colored x is actually the time that elapsed. Right? So this is the time axis, this is the position axis. And this ideally should have been 0, but what it is in real life is it's where the buggy started, which is a position of 0. So we're going to call that x naught, and I'm going to denote that as the initial position. So we end up getting an equation, and there's one last thing I want to point out, which is this little number here. If we were to actually measure its units, it would be 0.4 meters per second. And then whenever I ask people, well, what does that mean in real life? They're like, well, it's the rate at which the car goes forward given a certain time, or it's how far the car goes in a certain amount of time. And I said, we have one word that sums that up. Do you know what that word is? And we think, and we realize, aha, that's the speed, which we're going to denote as v naught. So v naught is the car's steady speed. Okay? Before I put all this together in the correct linear equation that we're going to use in AP Physics, I also want to show what the graph for going backwards looked like. So when we went backwards, we had a similar set of axes. Again, we have position and time labels. And here we start off at about 200 centimeters, right? And then we kind of notice our car going backwards in time. And when we draw the graph, we end up getting a graph that looks like this. So the slope is downwards. And we get one more additional piece of information. When we actually ask Wolfram Alpha to give us the equation, we get something like y equals negative 0.38x plus 200, or plus 2.06, right? So all of these things apply, but now we learn one more fact. The negative sign. In real life, it does not mean decelerating. It does not mean slowing down. That's our first temptation to say that. It actually means that we are going backwards. And once again, our starting point is 2.06 meters according to the equation. That's just a little bit of calculational error based on our measurement errors. Not really calculation, it's a measurement error. The truth is we know that it should have started at about 200. So when we put all this together in the equation that we use for AP Physics, what we basically say is that the position of a car moving at steady speed depends on its velocity multiplied by the time that it goes at, plus whatever initial position you start at. And negative V naught means we're going backwards. And positive V naught means that we're going forwards. Okay. Now, one thing I want you to think about, just as a little brain teaser, suppose my axes look like this. I have a red car that goes with this graph, or not with this graph, but when I plot its position versus time, it looks like that. And the blue car looks like this. So red and blue. And the thought I want to leave you with is, which car is faster? And why? All right, so that is a summary of the lab that we did, and I hope that's helpful.